Hi, I'm Dr. Eseryel, and I would like to now present to you my article called IT-Enabled Knowledge Creation for Open Innovation. This paper was published at the Journal of the AIS. Well, let's start with the motivation of the study. But first of all, let's describe open innovation. Open innovation is the process of systematically exploiting the internal and external knowledge sources for accelerating innovation. So companies have been really interested in open innovation because of the shorter innovation cycles. There's the high level of competition and the rising cost of development. With open innovation, they can benefit from not only what their own employees create, but also the creation and the knowledge of external sources that the company doesn't pay for. Innovation helps address critical problems in software development. So it is really at the core of software development. Therefore, it's very important to study innovation in the software development setting. And we can see that there's a move towards openness in the software industry. So, for example, IBM has been for a long time paying their employees to work in the um, open source software projects, and in return, these employees have been using open source in the software that they're developing for IBM. Similarly, Nokia had a different model where they had a very strict control of the software, the applications and the games that was developed for Nokia phones. However, they also incorporated the open source community by saying that they can contribute to the development of these tools. However, at the end of the day, the main personnel at Nokia would decide which features and applications would be the final ones selected for the next version of Nokia software. The research gap in this area is that we still do not understand how different methods and technologies can facilitate innovation in software development, and my research addresses exactly that. So I'm looking at the use of the role of open information and communication technologies in open innovation within the software development context. Well, so my challenge was, how do I measure open innovation? How do I operationalize? How do I see an instant of innovation? If you look at the literature, you find that most often people are looking at some sort of outcome, a software, a product, and then they say this is innovative or not. And I wanted to actually capture instances of innovation. So I went back to the book of Nonaka and Takoichi, which is the core book cited about innovation many times. If you read this book, this is a fantastic book. They went to Japanese companies and they identified with very exciting and interesting to read stories how these Japanese companies innovated. And what they ended up saying is that actually these companies create knowledge on a continuous basis, which creates a continuous innovation cycle, which brings about competitive advantage. So at the core of their study is that exploiting internal and external knowledge brings about open innovation. So I decided to use knowledge creation starting from their stories to investigate how innovation takes place on a day-to-day basis within open innovation communities. Now I have two research questions. One of them is, how do open source software development teams create knowledge? And the second one is, what is the role of IT in these teams? I have some sub-questions for the first one. So what are the knowledge creation modes? And the second one is about the role of internal and external knowledge, namely how do developers contribute to knowledge creation. This is internal knowledge creation. And how do the users, meaning external people, contribute to knowledge creation in these teams? Well, to answer this question, I selected a very innovative team, which is innovative both at the process level and the product level. At the time, so Apache Lucene Java is this case, and you might know of Apache teams from the Apache server, which was extremely successful. And after Apache server became successful, actually the team built a foundation around it called Apache Software Foundation. And currently under this foundation there are hundreds and perhaps now even more than 100 open source software teams that reside there. I went into the field, and by interviewing with the foundation members, I identified Lucene Java as a very innovative team to investigate. Lucene Java is actually a search engine. So if, for example, you have a new website and you want to provide a very powerful search engine, you would incorporate Lucene into the website. Now, it was seen as a process innovation at the time because it was one of the earliest search systems that used the open source model. With this model, the customers could really easily build search into their applications without going through contracts, negotiations, and licensing fees. As you might know, von Hippel and von Groh identified this innovation model used by open source as private collective innovation model because really the participants, the team members, they use their own resources, their own technology and own time to privately create a very novel software code, and then they reveal it publicly as a free good. This was Lucene Java was also a product innovation example because of the novel architecture that was used at the time. It used a scalable indexing method. So with this method, the index was incrementally changed and updated, and therefore the search engine provided better results despite the changes in the website. It also was object-oriented so that developers could easily extend and customize its functionality. Now it's possible to find this architecture in search engines right now, but at the time, again, it was a product innovation as well. I used archival data for this study because the archival data is usually known as the secondary data source, but in this case I treat it as a primary data source. The reason being, everything that happens in open source software communities happen online. So they use, on the left I have a list of 4 different tools. They use developers listservs to communicate among the developers. They use users listserv to where users can post their questions, their challenges, their knowledge requests in this listserv, and then directly communicate with the developers. They use Jira for project management. So where it's very interesting. Actually, when I was talking to them, I had this project management experience, so I kept telling them, well, how do you manage your projects? You know, what tools do you use? Who does the project management? And they told me, we don't have a single system like a MS project where one person is in charge of the project. Instead, we use Jira, which is an online tool that everybody, every individual, internal or external, can upload, can put their request for a change. If they find a bug in the software, they can actually put it there. And any person in the team can go in and say, I would like to take this line and I would like to resolve this issue. So they put tasks, they assign tasks to themselves, and they put information on the resolution. So in fact, Jira is in my opinion, is an online shared project management tool. And lastly, SVN is where is the technology where the source code resides. And it's very unique in that it enables software developers to work on the software simultaneously. So they could actually, two people or more people can check out a piece of the software code, which might be the same piece. They could make changes on it and then they could submit it simultaneously back in if they wanted to, without causing any problems, because the system will consolidate the two different softwares that were checked in. Now, I mentioned I see this archival data as almost a source of primary data, because when you look at these, you're actually experiencing what's happening in the team just like any other team member, because most of the time they don't see each other, and they communicate, collaborate, and coordinate with the use of these four tools. Now, I have identified 552 messages which from all these four sources, and I used a case study using these data sources. What I did, you see that my data is split between regular contribution threads and crucial event threads. Now, at the time, I was doing research on open source software, and we knew that it was very important. The releases that they make were very, very important. And I was sure that I should have studied part of this data, and the data is huge, so you cannot study it all, and so the sampling is actually an issue, to make sure that you're really investigating the right thing, capturing the truth in the way that it happens. So when I went into the field to interview with these team members, I was pretty sure that I should look around releases. So sample data, maybe right before, right during, right after the release, to capture the most important things that were happening. And even though I was so sure of it, I did something interesting. I went to the team members and I said, "This is what I want to do to capture what's going on in your group, and tell me where I'm going wrong." So what's so interesting is whenever you say, "Tell me what I'm doing wrong," they're sure to tell you what you're doing wrong, and I was thankful for that. Well, what they told me was that the releases they did not actually see as the most important thing happening, because they said the most of the development just happens over time, and by the time you come to a release, there's a pregnant point. Most everything is done, so the release is just putting together the last bits in a package, releasing it and testing it. So what you should do, they said, is look at what's going on a day-to-day basis, and you should also look at some of the areas where we're having huge problems. So I looked at regular contribution threads, which were actually collected from the 6-month period previous to my interviews when I talked to them. And I also looked at crucial event threads, which were in that 6-month period, I identified issues that were some sort of blocker that blocked the release, that, for example, major licensing issues that might stop them from continuing ever. So these kind of crucial events, I've selected them, but there were many of them, and then I ran it by the team members to find the most important ones that based on their experience. Well, so to analyze the data, I collected and sorted the archival data into threads. I imported the data into Atlas TI in order to analyze it with Atlas TI. Then the next step, which I'm going to talk to you in detail, is how I adapted the Nonaka and Takuichi model to the open source team setting, and I developed a deductive coding schema. Then with me and another independent analyst, we developed a content analysis schema. We established the reliability of the schema at 86%, And once the schema was reliable, I analyzed all the data myself based on using this reliable schema. Now let me talk to you about the steps of data analysis. The 4 knowledge creation modes on the left are the modes that are identified by Nonaka and Takuichi. And they're basically talking about how do you take somebody's tacit socialization, how do you take somebody else's tacit knowledge and convert into your tacit knowledge in your head. The second one is how do you take your tacit knowledge and then make it explicit to others by communicating. So I took these 4 and then I created a completely new schema based on how based on how it would be observed in the open source software development setting. Well, this is in this process. This process was interesting because when you look at Nonaka and Takuichi, they don't set specific rules. They don't talk to you about how you could analyze archival data. What they do is they tell stories. So the way I came up with this schema is I understood the core of the stories they told, and then I would say, well, how would a similar thing be observed in open source? And therefore, I identified specific behaviors for each of the creation modes and provided descriptions. Now, I will tell you how I did these 4 very clearly, because otherwise, when I show you the findings, you will not believe what I say. Socialization is the first one. Basically, socialization is how do you take somebody else's tacit knowledge in their heads without them explaining to you what they've done and really understand it? So socialization is about shared experience. I must warn you, socialization is not about is the research term used here is different from socialization that we see in real life, saying, hi, how are you, let's drink beer together and let's be social. That's completely different, although the term is quite it makes us remember that socialization. But what they call socialization is observation, imitation, and practice. That's how it happens. For example, Matsushita Electric Industry Company, they wanted to come up with a bread making device, and they didn't know how to do it and what would make a good bread. So the chief engineer actually went to the best baker in their city, and she did an internship with the baker. So what she realized by observing and by imitating is that the baker moved the dough in 2 directions. So he would push from the from the top, and then with his right hand he would turn it simultaneously. So then she realized that to make bread successfully, the device needed to turn in 2 directions. So you would see in the device, actually the top part turns and the bottom part turns as well. Luckily for them, they weren't trying to make pasta the way Chinese did. Instead, they were trying to make bread the way Japanese did. Because in my observation of the pasta makers, they actually take this huge dough and then they swing it around. So that would actually make a huge machine that nobody would be willing to buy. Open source socialization. So how do you operationalize in open source setting was a challenge for me, because they don't have they're not like agile teams that, in agile teams you would say, okay, they sit down together, they write code together, and they discuss. So there would be the observation, imitation, and practice. However, in open source teams, they don't even see each other. So in fact, I went to their conferences, and we have a paper on the face-to-face aspect of open source from 2007, I believe. And I saw them sit around a table and not even talk to each other. Well, they had a very good reason to do that. They didn't want to exclude the people who could not come to the conference. However, it's, you know, it is such a good evidence that even when they could see each other face to face, they don't do the socialization the way it happens in other settings. What they do is through the source code. Actually, Hefliger and von Groh, in their 2004 paper, they say that these team members transfer their tacit knowledge through shared artifacts, such as the source code. So um, when the shared artifact is something that they could then look into, study in detail, break down, and then learn, so that they can capture the tacit knowledge of the person who wrote the code, and then they could use it going forward. So for socialization, we use submitting bug reports, submitting patches, committing patches as ways where tacit knowledge from one person was transferred to the other. Externalization is articulation of, this is the second knowledge creation mode, is the articulation of tacit knowledge into explicit concepts. So the researchers observed that in product development setting, and they found that they used many metaphors and analogies. So they would, for example, in creation of a new car, they would in the past they focused so much on the engineering and the technology and high-tech expert, but then at a certain point they said, yeah, but we cannot sell these cars. What should we do? They came up with a metaphor, man first car, saying what's important is the experience of the humans. So give room to humans, focus on the human experience instead of just the cool technology. Well, again, another challenge is how do you convert this to open source software setting? Because I went back for about a year in the archival data and I could not see any examples of metaphors. I mean, open source people are engineers, are software developers. They don't go to metaphors like, let's make this software code, it should be so beautiful, beautiful as a flower or something. You just don't see that, and nobody would appreciate that, I guess. Instead, what I saw was very fascinating. They really conceptualize problems and new ideas. They explain, they evaluate, they reject, they correct and defend an opinion on mailing lists. So, for example, if they wanted to come up with a new and come up with a solution to a problem, they would say, here is my solution. They write maybe a code or maybe a sample of the code or describe how it should be solved. And then they would back up their choice. They would say, I picked this one, this choice, this solution because it overcomes these disadvantages, and this is how I continue communicating. They really externalize their tacit knowledge very explicitly and clearly. Well, this was surprising to me to observe because I remember back when I was doing my PhD, before I went to do interviews with them, one colleague of mine who was more senior in the program came to me and said to me, Yeliz, if you ask a question to them and then there's this pregnant pause for about a moment, then don't panic, just hang in there. These people are not very socially apt, so they might just take some time to answer your question. It actually wasn't the truth in my experience. My experience was that open source people were very smart, very explicit. They knew the role of open source in the world. They had vision. So it wasn't my experience. And surely I could see it in the archival data as well. They clearly externalized their tacit knowledge in a way that's very difficult to many people. So externalization codes were contributing to problem resolution by providing information, making suggestions, explaining logic behind suggestions, and asking questions to somebody's related to somebody's suggestion to bring out more knowledge, and mentoring and guiding others by specifically saying what they should do to be better collaborator, better contributor in open source area. So we've covered the first two knowledge creation modes. The last two are actually operationalized the same way in open source as in other teams that Nonaka and Takuichi observed. This combination is the conversion of explicit knowledge to other forms of explicit knowledge by reconfiguring existing information, to sorting the information, to adding, combining different sources of information, or categorizing them. What I've seen in open source was they actually recombined information that resided in several different information systems. So remember the four tools that I showed you earlier: different listservs, source code, issue trackers. So they would actually get information from several sources and update the issue tracker, for example. Or they would refer users to knowledge sources that reside on a website or on another listserv or on Jira. So this is how they did the combination. And the last one is internalization. Now, actually, a lot of people, including myself, have some challenges in understanding the internalization that's operationalized by Nonaka and Takuichi, because they basically called documentation as internalization. So, and the reason why they did it is if you go back, as those of you who have any IS experience in the field, remember the first years that you were on any IT job. I actually did IT help desk, which meant that I actually sat down, wrote documentation of the software. I mean, it's the most boring thing to do, and I answered phones also, but. This is the process where you learn the most about an information system. Because as you're documenting, you're clicking, you're looking at different aspects of it, and you're diagramming, making the knowledge explicit. Many people have a problem with that because this internalization, if we go back, on the bottom, its internalization is making explicit knowledge tacit, because in this process of writing documentation, you make an explicit knowledge into your own tacit knowledge in your head. Well, many people have the question, well, if you document, you create an explicit knowledge, which is actually the output you have is the documentation, is an explicated document. I understand that, and I had the same problems when I was doing the research. However, here, what's captured is during the process, the person who's doing the documentation does internalize, making the knowledge tacit for themselves. Now, they're externalizing some information, and for this study, to avoid double coding, I have not coded as an explication. So in this case as well, I've done exactly what Nonaka and Takuichi did and called documentation as an instance of internalization. So this is the end of my explanation of the four different types of codes and how I operationalize them.